Hi there and welcome to this video tutorial on Python programming, and the topic of this tutorial is functions. So if you have viewed the previous tutorial on types and operators, you'll have seen me typing single lines of Python code into the console down here and looking at the output that comes out. Of course, most programs contain more than a single line of code, and you want to run multiple lines of code, and to do that we're going to start typing code in the text editor up here. So I'm just going to type some lines of code in here, which should look fairly familiar if you've seen the types and operators video tutorial. I'm going to create a variable called a, and I'm going to assign it the value 9. I'm going to create another variable called b, and I'm going to assign that the value 2. Now I'm going to create a third variable called c, and I'm going to assign to that a multiplied by b. And a fourth variable I'm going to create called d, and I'm going to assign to that a to the power b. Okay, I'm going to save my program. So that's a simple program. It's just 4 lines of code. And now I'm going to show you what happens when I run the program. I'm going to run the program using this icon up here. This is a special kind of running called debugging, where I'm going to run the program. Instead of trying to run all 4 lines at once, I'm going to run them one at a time. So I'm going to press this button here, and you'll notice that line 6 of the text file becomes highlighted. Then I'm going to press this button next to it in order to skip on 1 line at a time. So if I click that once, it'll move on to the next line. And notice that it doesn't move to the next line of the file. The next line of the file was line number 7 here. It actually ignored that because there was nothing written on it, and Python doesn't really care about blank lines. It'll just ignore them. So it skips on to line number 8. And now if I execute line number 8 by clicking this button, I've created a variable a in memory, and you'll notice if we look over here, this top window, this is called the Variable Explorer. To make sure you can see this, first of all, make sure your Variable Explorer is open, View, Windows and Toolbars, Variable Explorer, make sure it's selected there, and then just make sure that it's the active tab and that you haven't got it's not hiding behind one of these other tabs. Okay, so Variable Explorer. So Variable Explorer shows us all the variables in memory. So we've got an object in memory and of type integer, value 9, and variable name a. Okay, so if I skip over the next line, line 9, we get value 2 assigned to variable b, and we get a new variable in memory called b, integer, value 2. Again, notice how we've skipped over the blank line. If I execute that line 11, we get a new variable c with value 18, because that's 9 times 2. And if I execute the final line, d, I get d, a new variable, integer in memory with value 81, which is 9 squared. Okay, so what Python's done here is it has simply executed each line of code one after another, and it has created 4 objects in memory, 4 integers, a, b, c, and d. If I wanted to run all of the lines together, instead of clicking this run button here, I could click this red run file button over here, which would run all 4 lines together. We can do that now. So it'll just run the file. And so we've got our 4 objects in memory, and if we look down here in the console, it tells us that we've run the file. It says run file, and it gives us the name of the file that it's run. But what it hasn't done is it hasn't actually output any information. No information has come out into the console. It's just created these 4 objects in memory, and they're there in memory. We can see them, but nothing has been output. If we want to output something, we have to explicitly tell Python to output it. So we could add another line with the command print. So if we use the command print, then anything we put after here, Python will print out into the console. So for example, we could print d. Okay, I'll press save, and then I'll run that, and we'll see it's run again, and this time it's printed out down here, quite small. Make that a bit bigger. It's printed out the number 81, okay? Because D has the value 81. So now our program's up to 5 lines. Now the order, so you'll notice that you'll see when we run it in debug mode, that Python simply executed one line after another. And the order of the lines is important. So if I was to, for example, take this line here and cut and paste it and put it as the first line of the program, we would run into problems. So if I now start to run and debug, I'll go run, I'll step, and I'll try and execute this line, C equals A times B. Nothing happens. Nothing appears in my variable explorer, and in fact if I look down at the console, I get told there's an error, a name error. A is not defined. And in fact, even more helpfully, Spyder has put this little sort of warning symbol here telling me that I've got an undefined name A, and an undefined name B. Because of course I'm telling it to multiply A by B, but I haven't created A or B yet. And trying to use them before I created them has resulted in an error, or what programmers call a bug. Basically a problem with my code which prevents it from running properly. So the order in which the lines of code execute is important, and so having them execute in the correct order is important, but you don't really want to have to type every single line in the correct order. There's all sorts of reasons why that would be problematic. And one obvious reason was if you wanted to run the same, if you wanted to do the same thing more than once, you don't want to have to type it in one place and then type it again in another place, or even in multiple places. You might want to do something 100 times or 1,000 times. And so you don't want to just write lots and lots of lines with lots and lots of duplication, with many of the lines essentially saying the same thing or a very similar thing. And so it's good to apply some structure to your code. We'll just correct this bug here and run it again. And the basic unit of structure in programming is something called a function. Okay. Now I'm going to create a function in here. In fact, what I'm going to do, just to be contrary, is I'm going to create the function in the middle here. This will help when we run this later on. This will help us understand how this works. So a function is like a little machine. It's a small block of code which takes some information, some variables usually, as an input, and then does something with those variables, and then outputs another variable. So if you want to create a function, the best way to see this is just by example. So if I want to create a function, I type this keyword def, and then I need to give my function a name in the same way as I've been giving my variables names like A, B, C, and D. I give the function a name, and I could just give that a name like E, but in fact it's good practice in programming to give your functions what we call verbose names, which is a name that describes a bit what the function does. So I'm going to call mine circle area from diameter. Okay. Now there are certain rules about the names of functions, and one of those rules is you're not allowed to have spaces in between. You're not allowed to have spaces in the function name, the space character. So my function name is several words stuck together, and what I've done is what's called camel casing. I've done into all the letters lowercase except the first letter of each word, so it's easy to see where the delineation in words is. Circle area from diameter. Okay, so I've defined a function and I've given it a name, and the next thing I need to do is define the inputs to the function. Okay, a variable or variables that are input to the function, and I do this by open brackets, and I will create a variable called D, I'll define a variable called d, and that's the input to the function. If I wanted to input multiple variables to the function, say I wanted to give it 2 or 3 different variables, I can also define this here. I just need to separate them by a comma. So this function would now expect 2 variables, d and e, and this one would expect 3 variables, d, e, and f. But our function, as you may have already guessed, is going to calculate the area of a circle from its diameter. So the only variable we need is we only need one variable, the diameter, d, and we'll put that in here. And then finally, we put this colon symbol, which indicates that the contents of the function are about to follow. So we've just defined the function name and the inputs to the function, a single variable called d. Now when I hit return, you'll notice that Spyder has automatically indented the cursor, so any text I now type is indented. The indent indicates that the lines of code here are within the function, okay? And if I was to, so I could put a line in here, so I could create a variable, which we've been used to doing. That would be a line of code that would happen in the function. If I get rid of the indent, that's essentially the end of the function. That indicates that what I'm writing now is no longer within the function, it's just a regular line of code. Okay, but I'm going to stay within the function because I need to create my circle area from diameter. Now there's another convention in writing Python functions, which as well as giving your function a verbose name, you also give it what's called a comment string to explain what the function does. And I'm just going to write the comment string, and then I'll explain what's going on here. I'm going to say this takes a float d defining the diameter of a circle and returns the area of the circle. Okay. Now, if you watched the tutorial on types and operators, you'll see that this looks a little bit like a string, except instead of enclosing it in single quotes, I've enclosed it in triple quotes. And what this is, it's not a string, it's what's called a comment. It's basically text that I can write in my file that the three quotation marks either side of it tell Python to ignore it. So it's text that Python ignores, it never gets run, but for a human looking at the file, it helps them interpret what's going on. Okay, so this is just what's called a comment string at the beginning of a function, explaining what the function does, and it's kind of good practice. So now we want to calculate the area of a circle. So the area of a circle, I'm going to create a variable called area, and I'm going to assign to that pi, which is 3.142 roughly, times the diameter of the circle, which is d, squared, and that whole thing I'm going to put in brackets and divide it by 4.0. Notice how I've used 4.0 instead of 4 to make sure I don't have any problems with integer division. And so that's what I want to calculate, and the area, and then I want the function to return the area. So remember, a function is like a little machine, it has input and output. The input is d, and the output is area. In order to instruct the function that we want area to be the output, we need to use this special keyword called return, and the function will return the area. Okay. Now, I want to show you how this works, and in order to do that, I think I'm just going to run. I'm going to step through the code line by line again. So if we go back and we do what we did before, we're still running. If I press run and step, in fact, sometimes these variables will remain in memory. If you want to just clear clear all your variables out of memory, you can just type this reset command in the console, and you'll get rid of all the variables in memory. So let's start again. Let's run. Let's step. So first line of the code, we create a variable called A. Second line of the code, we create a variable B. Then we define this function. And notice if I press execute, notice that Python notices it sees that a function's been defined, but it actually ignores all the code within the function. It doesn't actually do anything. It just skips over it and goes to the next line. And notice how it's now dropped down to this line C. And we execute that, and we execute that. And we see we've got our variables A, B, C, and D in memory. We've got nothing about small d or area and nothing about the nothing to indicate we've got this function at all. And if we execute the last line, it will print D, and the program will finish. So even though we've written all this code in this function, Python hasn't actually done anything about it. In fact, it's more or less ignored it when we ran the program, and that's because a function is not code. How to say this? This is a definition of a function, hence the def keyword. We've defined some lines of Python code that could be executed, but they won't get executed until the function is actually used, until the function is employed. Okay, and so for example, if we come down the bottom here, we could create a new variable that we can do what's called calling the function. So I'm going to create a variable called E, and I'm going to call the function. And you call a function by typing its name, circle area from diameter, and giving it a value. So, for example, we know we've got some variables in memory. We've got the variable A. We could pass it A. Okay. Now, yeah, sorry about that. Somebody knocking on my door. So, so where was I? Yes, we have called the function. So we've created a variable E, into which we're going to put the output of the function circle from area diameter, and as the input we're giving it the variable A, which we already created in memory up here, A equals 9. So look, I'm going to step through it now and see what happens. So run, step. At this point, A defines the variable A. Look at the variable explorer, we've got it in there. Ignores the function. We look at the variable C equals A times B, D equals A to the power B, prints out D down here, 81. And now it's going to run the function. And so we create a new variable called E in our variable explorer, which is 63.625, which I hope is the area of a circle with diameter 9. Okay, now that's all very well, except we didn't really see what happened very much there, so I'm going to do that again. I'm going to stop that. I'm going to reset the variable space so it's all empty, and we're just going to run again, and I'm going to show you a little trick you can do here. So we'll step A, step, ignore the function, C, D, print D. Okay, so when we get to the function line here, instead of pressing step, if we press this other button just to the right of it, what it will do is actually step into the function that's being called. And so this is actually how the lines of code execute. So it executes this line, this line, this line, this line, this line, and when it gets to here, E, we employ this function. It then jumps back up to this line, and if we now step, you'll see it actually goes through and executes each line in the function. So it executes this line where we do this calculation, we multiply 3.142 by the diameter squared divided by 4, and that goes into a variable called area. And you see now, if you look in the variable explorer, we've created this variable called area. It's got the type float, okay? Because even though a was an integer, we defined this as a float and this as a float, and when you multiply floats by integers, you get floats. And then finally, it returns the function area. And by return, that just means it pipes it out and into the variable here we've called e. So I'm just going to do that one more time and mention a couple of other things. So let's just, does that work? Yeah. Let's just do that one more time. Run step, 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 step in. So notice when we cut, here we go, there we go, this is the other thing to notice. So when we're inside the function, notice we've got a equals 9. We've also now got this lowercase d variable in memory, which is also an integer with the value 9. Basically the same as a, because what we did, we define here in the definition of the function, we define this variable called d, which we say is the input to the function. But what we don't want to do is, whenever we call this function circle area from diameter, we don't want to always have to remember what we defined the input variable to the function was going to be. So we want, Python's very flexible and we can pass any variable with any name to the function. And so what it does here is we pass the variable a, which is a variable pointing to the object integer with value 9 in memory, and that object in memory now gets, within the function, gets referred to by this other variable called d inside the function, inside the scope of the function. Okay, so we step through the function and create area. So we've kind of got these things, d in area, and then return out of the function. Whoops. Okay. So, and in fact, in general, it's good practice to have almost all, it's not really good practice in writing Python programs to do this at all, really, to have sort of lines of code just executing on the main, just executing here. It's good really to have all of your code inside functions. Okay, so what I'm going to do now is I'm just going to get rid of that and that, and we'll have we don't have any variable called a now, so I'll just put that in there. And I'm going to create another function just for completeness. I'll show you another function. So here I'm going to create a function called circle area from radius. Okay, equals r. I'm going to pass it a single variable, which I'm giving the name r, and I need to give it a comment string like this. Takes a float r, defining the radius of a circle, and returns the area of this. Oh, I see, I've got some bad spelling there. There we go. Correct that here. So what I could do with this function is I could just do area equals 3.142 times r squared, squared divided by 2.0, like this. But a slightly more elegant way than that would be to actually make use of the function we've already created. So the radius is always half the diameter of a circle. So what we could do is say within the function area equals, and then call our previous function that we've already created, circle area from diameter. Maybe actually what we should do is first we'll define a variable called d equals 2 times r, and then area will pass that d. Okay, and then return the area exactly as before. Okay, so Now I'm going to change this now to radius, and I'm going to give this some value. Let's say, I don't know, let's just give it 5. Okay, so I want to show you what happens now when I run this code, when I step through. So let's have a look. Reset. Yeah. Okay. So I'll press run here. We'll step. So the first function definition is noted. The second function definition is noted. Here we call circle area from radius and we give it an input of 5.0. So now I'm going to step into that function. And notice we've now got r in memory. We've got a variable in memory called r. Its value is it's a float. Its value is 5.0. So that basically this number here we've got in has gone into the function as r. First line of the function, we create another variable called d. If I step, then we get this variable in memory called d, float with value 10 because it's 2 times r. And here we now call the other function. So if I step into that, you'll notice we now jump up here. We're now running this line. And we calculate the d now is, notice how the other variables have disappeared because we're within the function. Okay, the variables within the other function, they're not within the scope of this function. So the only thing that's really within the scope of this function is this variable d. So our r has disappeared. We've just got this variable d now, value 10, and then we calculates an area 78.55 and returns it. Okay, which if we step, now that we end up here, we're now back in the circle from area from radius function. We've come out, we've got d, we can see r again because we're back within the scope of this function. We've got area 78.55 and then that's going to get returned. And then we'll jump down to here, and now outside all the functions, all the d's and r's have disappeared, and the only variable in scope is e, which is 78.55 because it's what this function returned and it's what we've assigned to the variable e. So this is another nice consequence of using functions, is that the names of things we define within functions like d and r and area only apply within the function. It's technically called a namespace, and that means that it's quite easy to keep track of what you've called your variables. You could imagine that if you had a long program with lots of a's and b's and c's and d's, you could easily forget that you'd used an a and reuse it somewhere else in the program. Whereas if you keep everything within short functions like this, then your variables, it's easier to avoid those sort of variable name clashes. Okay, so this code will be available on Blackboard, so you can download it from there and have a play with it yourself and step through it and see how it works. Another advantage, of course, of writing your code in functions is you can very easily call functions again, use them more than once. So I could say, if I do this, I can create another variable called f. If I save and run that, you see that I've now in my variable explorer, I've actually done the same process, run this function circle area from radius twice for different values. The first for a radius of 5, giving me this area, and the second for a radius of 110, giving me this much larger area as you would expect. Again, I haven't nothing's coming out of this program yet, so really what I should do is I should print E and print F so that I can see what's coming out the other end. If I just save and run that, you'll see I get my two areas printed out there. And of course I could evaluate other circle areas. So I think that's quite a good simple introduction to functions. So I'll leave that there for now.